Hi guys, today's topic is extracting metals in top series. In previous video, we saw about the middle and less reactive metals, how they are extracting by using the roasting and calcination process. Now we are going to see about the top series. These metals which is present in top series are very reactive or very sensible. They are very reactive. And these metals cannot extract directly by heating. So the roasting and calcination process here, it is not used. We cannot extract the metals by using the heating process. Why? Because means in the previous video we saw the metal oxides, they are reacting with carbon and they will produce the pure metal sulfide we taken, and it is reacting with carbon and we get metal oxides, and after that we get the pure metal. But here we can't do that method. Why? Means, for example, very reactive metals such as sodium, magnesium, calcium, aluminium and all, and these metal oxides and all have more affinity. These metal oxides have more affinity for oxygen more than carbon. Again I will explain. Listen carefully. The very reactive metals, sodium, magnesium, calcium and aluminium, these and all have affinity, more affinity for oxygen. These oxides, we cannot get this metal in pure state, we get in the oxide forms. So these metals have more affinity for oxygen than carbon. So this method won't set up for this top series metals. So that we are using the electrolytic reduction. Electrolytic reduction, and this method is used to extract the metal which is present in the top series. So these metals are electrolysis of their molten chlorides. We cannot get that directly, so they are getting in the formation of molten chlorides. For an example for electrolytic reduction, I am taking here sodium metal. I am going to separate the sodium metal. Okay, so the sodium metal from sodium chloride, I am going to separate this from sodium chloride. Before I said, and these metals are in the form of molten chloride, they are separating by using the electrolytic reduction. Electrolytic reduction means what we will do in one beaker. The salt solution will be, the metal salt solution will be here, and we will insert the two electrodes, cathode and anode. Then after passing the electric current, what will happen? The pure metal will go to one side and the impure metal will go to another side. So the pure metal will be go to cathode side and the impure metal will go to the anode side. So at cathode, what metal here we are taking? Na and Cl, sodium chloride, sodium Na and chlorine Cl. So at cathode, Na will deposit there. Na will deposit there. At anode, the chlorine will deposit there. So this is the method for the electrolytic reduction. And next topic is electrolytic refining. Refining means what? The extracting metals is not pure. It is in the state of impure state. So we have to purify these metals. So that what process we are using means electrolytic refining method is mostly used. Most of the metal like copper, zinc, gold, silver, nickel, most of the metal are used to purify by using the electrolytic refining method only. So in this method, as usual, we will use the one beaker, and inside the beaker the salt solution will be here. What metal we are taking, that metal salt solution, and we will insert two electrodes, anode and cathode. After passing the electric current, what will happen means the pure metal will go to cathode side and the impure metal will go to anode side. Some impurities does not dissolve in the solution and it will settle down in the under the beaker, and that solution inside just like the impurities will be settled, and this is known as anode mud. the impurities which is not dissolved in water, and that is known as anode mud. Again I will repeat, electrolytic refining method. I will say one example. For example, copper sulfate. We are going to separate the copper. Here inside the acidified copper sulfate solution we are taking here copper sulfate, and after passing the this is in blue color solution. After passing the electric current, the pure copper will go and settle down in the cathode state, and the impure copper Cu2 plus and the impure copper will settle down on the anode side. Some impurities, if they are present, means it is not dissolved in water and it will be settled down in the corner of this anode side. So that is known as anode mud. So this is the process of the electrolytic refining to get the pure metal. Next topic is corrosion. For example, corrosive metals such as silver. When the silver is exposed to air, after few days it will get some black color. Why? Because means this is react with the sulfur which is present in the air. The silver is reacting with sulfur which is present in air, and it formed silver sulfide. So only for example, the anklet, silver anklet, and all, after few days it will change its shining surface into black color coating. Little bit black color coating. Why? Because means the silver is reacting with sulfur which turned into silver sulfide. So only it is changing its color. And next example is copper. When copper is exposed to air, this copper is reacting with carbon dioxide and it loses its brown color, and green color coating will formed on its surface. Why? Because means this copper is reacting with carbon dioxide and it is giving copper carbonate. So only the brown color surface is changed into green color coating. And next best example is iron. Iron rusting. Iron is reacting with the moist air and it will form the iron oxide, which is known as a rusting of iron. So these are all the best examples for corrosive metals. We are going to do an activity for rusting of iron. For that I am taking 3 test tube. Test tube A, test tube B, and test tube C. I am naming these 3 test tubes as A, B, C, and in the first test tube I am pouring some water and I am inserting one iron nail. And in the second test tube, as usual, I am pouring some water, and also I am using little amount of oil, and this little amount of oil does not dissolve with water. It will be in the upper surface of the water. So here what are all the things I am using? Oil plus water. And I am inserting the iron nail here. And next in the third test tube, I am going to put anhydrous calcium chloride. Anhydrous calcium chloride. Then I am inserting the iron nail here. Okay, let's check. In the first test tube, what is present? Water. Water. And also, and this water is exposed to the air. Some of the air is also I am allowing to move inside the test tube, but here I am not allowing the air to move inside the test tube. Why? Because means I am stopped that air by using the oil. This oil does not allow the air to go inside of the water. So here water plus air is present, but here this oil is preventing the air should not go inside the water, and here I am using anhydrous calcium chloride. So here dry air only present. There is no water. So here dry air is present. After few days, check which iron nail get rust. Which one will get rust means the A test tube. Why? Because means here only the air is present. Here the air without moist. This is a dry air. So this B and C does not getting the rust. Only the A test tube iron nail is rusting. The brown color substance will form here in the surface of the iron nail. Why? Because miss, this ion is reacting with moist air and it is absorbing the oxygen, then it is automatically get rusted. But here the oil should not allow the air inside of the water, so it didn't get rust, and here dry air, so there is no chance to get rust. Prevention of corrosion. We are using many methods. For example, painting on the metal, painting, oiling, greasing, galvanizing. Galvanization is the best process. What does mean by galvanization? Means we are preventing the metal from the rusting by doing the thin layer of zinc on the metal. Thin layer of zinc on the metal, and that process is known as galvanization process. And next method, chrome plating, anodizing, or making alloys. And this method is a most commonly used methods. For example, ion will get easily rust. How to prevent this ion means, usually the pure ion is very soft, and when heat is applied on the pure state of ion, it will easily stretches. I am saying about pure ion. But to make this ion hot, what we are doing means 0.05% of carbon is mixed with this ion. Small amount of carbon is mixed with this ion, then only this ion will be very hard and strong. Very hard and strong. To prevent the rusting of this ion is mixed with nickel and chromium. Nickel and chromium. When this ion is mixed with this nickel and chromium, it will change into stainless steel. Stainless steel. And this stainless steel didn't get rust, didn't get corrosion. So in pure state, we can't use the ion because it's very soft, and when the heat applies on the ion, it will stretches easily. So 0.05% of carbon is mixing with that ion, then it will become very hard and strong. And also to make the stainless steel, this ion is mixed with nickel and chromium. When metal is reacting with another metal or non-metal, definitely its property will be changed. Its physical property will be changed. And alloy, I said no, this method is mostly used. What does mean by alloy means it is a homogeneous mixture of two metals or metal with non-metal. Another one example is gold. 24 karat gold is very soft and it is not suitable for making ornaments. So a few amounts of silver or copper is mixing with this gold, then only we can make that into ornaments. So in India, mostly 22 karat gold is used, which means 22 parts of pure gold plus 2 parts of either pieces of silver or copper. And some other examples of alloy. Alloy means what I said, homogeneous. Alloy means what I said. Alloy means a homogeneous mixture of two or more metals. It's a homogeneous mixture of two or more metals or non-metals. Okay. If one of the metal is mercury means, then that alloy is known as amalgam. Next, brass is a good example of alloy, and this is an mixture of copper and zinc. Next, bronze. This is also one of the best alloy, and this is a mixture of lead and tin. So the copper is used for electrical circuits. So this, like the metals, are preventing by using alloying. Thank you.